Hello everyone, today in this video we are going to learn about how to prove sine a minus b and cos a minus b by using geometric method. See, I have written here trigonometrical ratios of a minus b, angle a minus b actually, compound angle a minus b. What is to prove? Prove that sine a minus b is equals to sine a into cos b minus cos a into sine b. Okay, so for which we will consider once again the figure. Look at, in this figure we have a Cartesian plan and we are considering a ray OR1. It is revolving anti-clockwise direction. It is revolving anti-clockwise direction. Okay, revolving anti-clockwise direction. And it has made an angle A with x-axis at this point, at this position. At this position, it has made an angle A with what? With x-axis. Now, after that, after reaching here, after reaching at this position, after making an angle A, this OR1 ray start moving downward. That means clockwise direction. We will consider like that. Okay, that means it has reached at this position, that is OR2 position, OR2. Okay, and this OR2 ray makes an angle B with the first rays in clockwise direction. Look at, remember, OR1 makes an angle A with x-axis in anti-clockwise direction, and OR2 makes an angle B in clockwise direction with OR1. Okay, A is anti-clockwise, angle B is clockwise. Then what about this angle? This angle will be, that means angle ray OR1 makes an angle A minus B with x-axis. That is A minus B with x-axis. This angle will be A minus B. Now we will consider a point on OR1 ray. Let this point be P. Okay, so a point P is considered on OR2 ray. Okay, let this point be P, and from this point we are going to draw two perpendiculars, one on OR1 ray and the other one on the x-axis. This way, let this point makes an angle, certain angle or perpendicular, that is PQ perpendicular to OR1, and P say this angle be this perpendicular be M. So PM perpendicular to the x-axis or OX. Okay, one more perpendicular we are going to draw from point Q to the x-axis. Once again, one more perpendicular is drawn from the point Q at certain point on x-axis. Let this point be N. Let this point be N. Now we are going to draw a parallel line parallel to x-axis through point P. Let PR be parallel to the x-axis drawn through P. Okay, and the PR touches QN at point R. Suppose the parallel line touches QN at point R. Okay, so this is the figure. How the figure is drawn, I hope you have understood. First of all, we have considered a rotating ray or revolving ray. OR1, it makes an angle A with x-axis. After that, it has come back, that means clockwise direction. In clockwise direction, it has made an angle B with the first axis OR1. That means OR2 makes an angle B with OR1. Okay, after that we have considered a point P on OR2. From this point, two perpendiculars are drawn. One is PQ perpendicular to OR1, and the other is PM perpendicular to x-axis. After that, from point P, we have drawn one more perpendicular, that is QN perpendicular to x-axis, and one parallel line is drawn parallel to the x-axis through point P, that intersect or that cuts or that touch the line QN at point R. Okay, This angle is A minus B. We come to know because the OR1 has made an angle A with x-axis and OR2 has made an angle B with OR1 first axis. So first ray. Then definitely this OR1 will make an angle A minus B with the x-axis. Now, OR2 will make an angle A minus B with x-axis. Now, our task is to prove sine A minus B with the help of this figure. Let us consider this angle as angle X, this angle as angle Y, and this angle as angle Z. Let's see, this angle is considered as angle X, this angle is considered as angle Y, this angle is considered as angle Z. Now let us name this point of intersection B as K, suppose. Okay. Then the triangle OKN or ONK gives us, as you know, this is perpendicular, QN is perpendicular to x-axis, so definitely this angle will be 90 degree. If this angle is 90 degree, then clearly sum of the other two angles, that means angle X and this angle, what is the name of this angle? Only this angle, that is A minus B. X and A minus B together is 90 degree. So very clear, since it is 90 degree, sum of the other two angles will also be 90 degree. So angle X plus A minus B, together these two angles will be equals to 90 degree. Then only angle X will be 90 degree minus A minus B. That means 90 degree minus A plus B. Can we write? Yes, this is step 1. Okay, you can write it here as step 1, as step 1. Clear? Let us name it as question number 1. Number it as question number 1. Now, let us look at angle Y. What is Y? Look at X plus Y is equals to 180 degree. Why it is so? Because they are linear pair angle, isn't it? X and Y together is 180 degree because they are linear pair angle. So, in step 2, we will write step 2. X plus Y is equals to 180 degree. Then only Y angle will be equal to what? 180 degree minus X. Why they are 180 degree? Because it is linear pair angle, right? Then X value already we have found in equation 1. We have X equals to 90 minus A plus B. So we can substitute that value here so as to get 180 minus 90 minus A plus B. If you remove the bracket, then it will be 180 degree minus 90 plus A minus B. So if you subtract it, then it will be 90 degree plus A minus B. Is that okay? Now let us look at this triangle. Look at the shaded triangle. In this triangle we have this angle is angle B, this angle is angle Y, and this angle is angle Z. B plus Y plus Z. Adding these three angles, you will get 180 degree because sum of the three angle sum theorem, isn't it? Then step number 3 will be angle B plus angle Y plus angle Z all together is 180 degree. So what did you say angle Z will be equals to? Yes, angle Z will be equals to 180 degree minus angle B minus angle Y. Is that okay? But Y value, we have already found that Y equals to this angle. Y equals to 90 plus A minus B. So let us substitute the value of Y here. Then it will be 180 degree minus B minus 90 degree plus A minus B. Is that okay? Then let us remove the bracket. If you do so, then it is 180 degree minus B minus 90 degree minus A plus B. Is that okay? Minus B and plus B cancelled each other. Then 180 minus 90 is 90. 90 minus A. That is Z. Clear? That means angle Z equals to 90 minus angle A. Now you know that from P, PQ was drawn perpendicular. isn't it? From P, PQ was drawn perpendicular to OR1, isn't it? OR1. So this angle will be, this whole angle will be 90 degree. This whole angle will be 90 degree. As you know, since PQ perpendicular to OR1, therefore angle we can write PQR is equals to, PQO is equals to 90 degree. Angle PQO is equals to 90 degree. But PQO can be written as angle Z plus angle PQR. Angle Z plus angle PQR together is 90 degree. Only Z is found as 90 minus A. So Z was found as 90 minus A plus PQR is equals to 90 degree. Let us shift this 90 minus A the other side, that side. Then what will it be? Only PQR will be 90 degree minus 90 plus A. 90 cancelled, and PQR is equals to angle A. That means in the figure PQR means which angle? Yes, PQR means which angle I say? This angle. PQR means this angle, and this angle measures angle A. Is it okay? Now let us begin to prove how to prove A minus B or sine A minus B. Look at, for this triangle, what is the name of this triangle? OPM. For this shaded triangle OPM, this angle is A minus B. Then let us apply sine A minus B. If this angle is A minus B, then sine theta will be perpendicular by hypotenuse. Then perpendicular will be PM. Side opposite to mentioned angle, this acute angle, side opposite to this angle is perpendicular. So perpendicular to hypotenuse means OP. Okay. Look at how I have written. Right angle triangle OPM implies sine A minus B is equals to perpendicular by hypotenuse. What is perpendicular I say? That is PM. That is PM by hypotenuse. What is hypotenuse? OP. OP is the hypotenuse. Now PM is equals to Rn, isn't it? PM can be replaced by Rn since they are equal. So PM can be replaced by Rn by OP. Now Rn, how can we write Rn? Can we write Rn as Qn minus Qr? Yes, Qn minus Qr. From this whole line Qn, if we subtract Qr, then you will get Rn. So we can write it as Qn minus QR by OP is there. Let us separate it. Then if you separate it, then it will be Qn by OP minus QR by OP. Okay. Now Qn by OP, QR by OP. Qn by OP minus QR by OP. Is that okay? Okay. Now let us multiply each term. The first term by OQ, that is Qn by OP multiplied by OQ by OQ minus the second term, let us multiply it by PQ. QR by OP multiplied with PQ by PQ. Why and how we have multiplied? Let's see. Okay, before that, let us write like this: Qn by OQ into QR by OP. Can we write it as? Since they are multiplied, we can exchange their positions. Okay, so OQ I am writing this side. It is OP only. OP I am writing this side. Minus QR by PQ into PQ by OP. Once we do so, it will give us Qn by OQ. Look at Qn by OQ. Where is Qn? Qn by OQ. It covers which angle? Yes, this angle A. And for angle A, Qn is perpendicular. So perpendicular by hypotenuse means sine of angle A. So it will give us sine A. It will give us sine A into QR by OP. Look at QR by OP. Where is QR by OP? QR by okay, it was not QR. What was that? OQ. OQ was there, and I have written here QR. Look at, so it will be OQ. OQ. Correct it. Okay. OQ. If you observe OQ by OP in the figure, then OQ is, what is OQ? Look at OQ by OP. OP. It covers angle B. For angle B, this is base and this is, no sorry, there was the perpendicular, right? If it is perpendicular, then this will be hypotenuse. This is hypotenuse and this is base. So base by hypotenuse. OQ by OP, base by hypotenuse, that means cos of angle B, cos of angle B, minus QR by PQ. Look at QR by PQ. Where is QR? QR is this and PQ is this. This is angle A. It covers this angle A. QR by PQ, this angle. If this is the angle and here it was 90 degree. So if it is the angle, acute angle, and this is the 90 degree, then the side opposite to it will be perpendicular, and this is hypotenuse, this is base. What is given to us? QR by PQ. QR is the base and PQ is the hypotenuse. So base by hypotenuse is cos. So cos of angle A. It will be cos of angle A. Cos of angle A. Then PQ by OP. Let's say PQ by OP. Where is PQ? This is PQ by OP. Where is OP? This is OP. Okay, there was perpendicular. This angle was perpendicular. So this is angle B, perpendicular. This is angle B. So this is base and this is perpendicular, means it is 90 degrees. So it is hypotenuse. Okay, we are given PQ by OP. That means perpendicular by hypotenuse. That means sine of angle B. Sine of angle B. So sine A cos B minus cos A sine B. This is the proof of sine A minus B. Sine A minus B. Okay, with the help of the same figure, we can prove cos A minus B. How to prove cos A minus B? As you know that this angle is cos A minus B angle. Cos A minus B means base by hypotenuse. What is base here? Yes, base is, if this is O, then base is OM. OM by hypotenuse is OP. OP. OM can be written as OM can be written as ON plus MN. ON plus MN by OP. Let us separate it. If you separate it, then it will be ON by OP plus MN. MN can be written as MN is equals to PR. Okay, so MN can be written as PR. MN is equals to PR, so MN can be written as PR. PR by OP. Now, this line, I am going to start this line from here onward. So, cos A minus B is equals to, we get what? ON by OP plus PR by OP. Now ON by OP, we are going to multiply OQ. ON by OP multiplied with OQ by OQ plus PR by OP. We are going to multiply this with PQ by PQ. PQ by PQ. If we do so, then what will it be? Look at ON by OP. Oh, let us write it in order. First of all, ON by OQ I am writing, multiplied with OQ by OP, plus this side PR by PQ I am writing, and PQ by OP. Now ON by OQ, it gives us, look at ON by OQ. ON by OQ, it covers which triangle? This triangle. whose angle is angle A. So ON is the base and OQ is the hypotenuse. Base by hypotenuse is cos. So cos of angle A, it will be cos of angle A. OQ by OP. Look at OQ by OP. Where is OQ by OP? This is OQ. This is OP. Since this angle was 90 degree, this angle was 90 degree. OQ by OP, it covers this angle, angle B. For B, it is hypotenuse, it is base. So base by hypotenuse again, OQ by OP is base by hypotenuse. It is again cos of angle B. So it will be cos of angle B plus PR by PQ. What is PR by PQ? Let us see in the figure. PR by PQ. What is PR? PR. And PQ? This is PQ. Look at PR by PQ. Here it is 90 degree. This covers angle A. In this triangle we have angle A. For angle A, this is base, this is hypotenuse. Then side opposite to A is perpendicular. This is perpendicular. Perpendicular by PQ is given. So it is perpendicular by hypotenuse, means sine of angle A. This will be sine of angle A. Then we have PQ by OP. PQ by OP. Let us see in the figure PQ by OP. Where is PQ by OP? Yes, this is PQ. This is PQ by OP. Where is OP? This is OP. So PQ by OP. Let's see what is this. Okay, that is 90 degree. It covers this angle, angle B. If it is angle B and that is 90 degree, it is hypotenuse, then it will be base. It is hypotenuse, it is perpendicular. So PQ by OP, perpendicular by hypotenuse. Once again, perpendicular by hypotenuse is, yes, it is nothing but sine of angle B. So it will be sine of angle B. And here it is the solution. That means cos of A minus B is equals to cos A into cos B plus sine A into sine B. That is the solution. Okay. Now with the help of these four identities, we can solve several questions of this exercise. Let us start solving some questions from the exercise 7.2. The question is, using the formulae for compound angles, show that the first one is sine 45 degree plus alpha plus equal to cos 45 degree plus alpha equals to 1 by root over 2 cos alpha minus sine alpha. It's the simplest one. Okay. First of all, we will start from this part, and solving from this part we will get this answer, and from the middle part also we will start similar way, and we will apply the compound angle formula, and after that you will get this part. Okay, so let's see how to solve this. Okay, this is the question, and what the question says, using the formulae for compound angles, show that sine 45 degree minus alpha equals to cos 45 degree plus alpha is equals to 1 by root over 2 cos alpha minus sine alpha. Okay, it's the simplest question, I think. Very simple one. All of you can do yourself if you have understood the identities. The first one, we will start with this part and solving with writing identity, writing compound angle formula here, or applying compound angle formula for this part, you will get the answer, this one. And second time, or second part of this question is starting from this part, cos A plus B. You're applying the formula for cos A plus B and solving it, you will get this answer. So let's see how to solve this. So first of all, I have written the first part, that is sine A 45 degree minus alpha. It is of the form sine A minus B. As you have already come to know that sine A minus B is equals to, yes, sine A cos B minus cos A sin B. So it will be sine A is 45 degree here. So sine A cos B. What is cos B? Yes, cos alpha minus cos A sin B. What is cos A? Cos A means 45 degree into sin B. Sin B is alpha. So sin 45 degree value, all of you know, that is 1 by root over 2 into cos of alpha minus cos of 45 degree is also 1 by root over 2 into sine of alpha. Now you can take 1 by root over 2 common. If you do so, then it will be 1 by root over 2 cos of alpha minus sine of alpha. Isn't it your right hand side? Yes, it is your right hand side. Then second part of this question is also One more part was given, that is cos of 45 degree plus alpha. Here also we will apply cos A plus B formula. What is cos A plus B formula? Just now you have proved. That was cos A, that is cos 45 degree into cos B minus sin A, that is sin 45 degree, into sin B, that is sin alpha. Cos A, okay, cos A plus B formula you have proved, proved in the previous video. Okay, if you go through that video, you will be able to know how to solve this one and how we have written the formula. Okay, cos A plus B is cos A cos B minus sin A sin B we have applied. So cos A means cos 45 degree. The value of cos 45 degree, all of you know, that is 1 by root over 2 into cos alpha minus sin 45 degree. It is also 1 by root over 2 into sin alpha. So 1 by root over 2 if you take common, then it will be 1 by root over 2 then cos of alpha minus sin of alpha, and this is your right hand side. Okay, so from both the sides we have completed the solution to this question. After that, question number 2 is, okay, here we will apply, it is this is the second question, and left hand side of the second question I have written. You can go through the textbook. Sin A plus B plus cos A minus B. Very simple. Sin A plus B formula we will write here, and cos A plus B formula also we will write here. Then it will be sin A plus B, sin A cos B, sin A cos B plus cos A sin B plus cos A minus B is cos A cos B plus sin A sin B. After that, sin 45 degree, you know that it is 1 by root over 2 cos of alpha plus cos 45 is also 1 by root over 2 sin of alpha. Then cos 45 degree also it is 1 by root over 2 cos alpha plus sin of 45 degrees also 1 by root over 2 sin alpha. See, 1 by root over 2 cos alpha, 1 by root over 2 cos alpha 2 times, and 1 by root over 2 sin alpha, 1 by root 2 sin alpha 2 times. So 2 times 1 by root over 2 cos alpha plus sin alpha, it is there. So you can cut it as root over 2 into cos alpha plus sin alpha. This is the solution. Okay, so hope you have understood. Then third question. Here also you take the left hand side of this question, and left hand side will be sin theta minus 60 degree plus cos theta minus 30 degree. This is very simple one. Here you will apply sin A minus B formula, and here you will apply cos A minus B formula. After that, sin 60 degree value we will substitute, and cos 30 degree value also you will substitute. After substituting the values, you will get the answer. Look at how to solve. Sin A minus B is sin A cos B minus cos A into sin B plus cos A minus B formula is cos A into cos B plus sin A into sin B, that is 30 degree. Is that okay? After this, cos 60 degree means you know that it is, yes, what is cos 60 degree? Cos 60 degree is root over 3 by 2. Okay, then sin of theta minus sin 60 degree is also root over 3 by 2 cos of theta plus cos of 30 degree, sorry, cos sorry, this is not 1 root over 3 by 2, it is half. Cos 60 degree is half, sin 30 is half, cos 60 is half. Okay, so cos 60 is half of sin theta, half into sin theta, then minus sin 60 degree is root over 3 by 2 cos of theta, plus cos of 30 is root over 3 by 2 cos of theta, then sin of 30 is half, plus half of sin theta. I'm writing this half in front. You can see that there is negative root over 3 by 2 cos theta and positive root over 3 by 2 cos theta. They will get cancelled. Then half of sin theta one time plus half of sin theta one time. 2 times half of sin theta. So it will be 2 times half of sin theta. This half and 2 will get cancelled, and ultimately you will get sin of theta, which is your right hand side. So in this way, in a simple way, you can solve all these questions. Question number 4 says, look at the left hand side of question number 4 is cos 70 degree into cos of 10 degree plus sin 70 degree into sin of 10 degree. This is the question of question number 4. It is simply of the form cos A plus cos A into cos B plus sin A into sin B. So cos A into cos B plus sin A into sin B. It is of the form cos A minus B. So cos A minus B. What is A here? 70 minus B. What is B here? 10. So cos A minus B, that is cos of 60 degree. And cos 60 degree, all of you know, it is half. So the right hand side is half. We have the right hand side half. This is the solution. Okay, so in this way you can solve all these questions. At least question number 1, all questions you can solve. There are few more questions, 5, 6, 7, 8. So solve all these. In the next video, we will try to solve few more questions, and we will try to understand more identities. Okay, thank you.